Have you ever wondered why that one guy from Palantir keeps repeating these few cliche phrases? Palantir is the cardiovascular system. Palantir is the connective tissue of an enterprise. Palantir is the plumbing infrastructure for data. In today's couple of videos that I'm putting out, we're going to be looking at just that. We're going to be diving deeper into why that guy, Palantir COO Shyam Sankar, keeps doing this. And by the end of this video, I'll hope to explain what I think this means, how they do this, and offer my personal analysis on what exactly this enables, including what Shyam has also mentioned on one earnings call. This is Jarvis, Tony Stark's digital assistant, but in real life. So welcome back to the channel and this Palantir deep dive. I'm going to be playing a little clip to set up the topics of discussion for today. But if you want to skip to my analysis, head on to the next chapter. Let's get started.
The second major area we call search and discovery. So by search, I mean that Palantir provides a single point of access, literally a single search box, that allows you to reach out and touch all of the various data sources in your enterprise. And we're not just talking about simple search. So we're not only talking about searching for what you know, we're also talking about tools to help you discover the things you don't know. So by that, I mean we enable advanced conceptual searches, allowing you to search on the basis of the relationships between things, the way a given network might look, as opposed to merely the things themselves. It means the capability to do persistent searches, where I describe to Palantir, these are the basic characteristics of the things that I'm interested in, the things that I want to look at. And Palantir will alert me to the emergence of new data that matches that pattern. And finally, we enable advanced geospatial and temporal searches so that you can understand what was happening or what is happening at a given place and time. Now, we do all this with an eye towards that concept we talked about earlier, with an eye towards reducing the friction between the analyst who has to make use of this big machine to do some task and the computer that he's trying to use, the data that he's trying to get at. So what that means is that we take all this data and make it searchable not just in a way that you're already familiar with, so not in a way that requires the user to be familiar with the underlying data formats and file formats and the various databases from which the data came, but by putting all the data into a model that the analyst actually understands. So I simply mean that you can search directly for people or events. I can directly ask the question, show me all the attacks that took place along this route over the last 3 weeks. I can directly ask the question, show me a heat map of all of the crimes that took place in my district over the last 6 months and how those are different from the previous 6 months. We make asking and answering these questions very easy for a non-technical analyst. Doesn't require somebody to do any programming and also doesn't require you to do any custom development for each new question that you want to answer. So search is really, really important. The ability to ask these questions and to get answers from your data is important.
So there are a few things to unpack here. Firstly, what is allowing this type of search and discovery? To answer this, we need to explore more deeply what ontologies are first. So in Foundry today, there's a layer called the ontology. This sits right above your data integration, data platform, data lake layer, and allows you to add the corresponding tags to objects and the corresponding verbiage between those objects, as well as the actions to be taken on these objects. This follows closely to the definition of ontologies you can find on Google, the branch of metaphysics dealing with the nature of being, and also a set of concepts and categories in a subject area or domain that shows their properties and the relationships between them. Ontologies can exist for anything, and they do. Examples such as categorizing animals. There's also ontologies for the hydraulic system of a car. Everything sort of has an inbuilt ontology. It just isn't always apparent to people. Language has an ontology in a sense. The parts of it can be the letters, then the words, then the sentences, then the paragraphs, for example. The problems we face when dealing with ontologies are how do we organize things in a way to communicate the full system? And another problem is that the further back you try to go in the general sense of an ontology to the core or the source or the beginning, the harder it becomes to define, categorize, and manage, especially when you try to combine ontologies of different phenomena. Say you have your animal, language, and car ontology, then the question is, what is the superclass that ties that together? The class above all of these that gets these in common. This is where Alex Karp's study of philosophy and his rigor in that area come in, and why I think they probably went this route in solving these issues with this ontology layer, and why is an important element to the overall solution at Palantir. And also why I think it becomes harder to replicate by just anyone else. This is my speculation, but hopefully I'm providing you the parts that fuel the speculation. In my head and how I think about ontologies in my words, I'm not an expert, so please correct me in the comments, but what you're basically trying to do is define or create categories of the phenomena you're observing as generally as possible, while respecting that if you go to the other side and become too general, you might be mixing and explaining a different category or superclass. And at that point, you have lost the idea of an ontology, which is systematically and logically trying to categorize phenomena for repeatable and reproducible work. An interesting group I stumbled upon when researching Palantir at the start was this other organization called the Foundry, which defines itself as the following. Now, if we change a few of the words, and again, this is me just asserting my eclectic research I've done. It may be true, it may not be true, it might be partially true, but this is what I think is ultimately Palantir's true value proposition and the main goal I think they're working towards, that I think will probably be hidden away from those not looking too closely, but will become more apparent over time as people use it and get the hang of it. Again, this is just my opinion, and I'm very happy to hear differing viewpoints. And going off that, I just wanted to add a disclaimer. Please do your own research. Try to tie it in with what you know, your experiences, with what your financial situation is. Ask yourself questions like, am I at the liberty to listen to some guy on YouTube? What if he's wrong? What is he not telling me? What are things he doesn't know? At the end of the day, I'm 25 with limited life experience, so really, what do I know? I've answered these questions for myself, so Palantir is worth investing in for me. I have a long time to wait. I have the capacity for me to be wrong about this and still look at it as a learning experience. And if anything, I'm making it a sort of productive asset for myself through this channel and the research I've done and the areas it has opened for me. So I just wanted to highlight the certain things I think you should consider when watching my channel or any YouTube channel for that matter. And hope you keep that in mind going forward. I'm glad we got that out of the way. So the next part to unpack is, how is Palantir doing this or letting you or enterprises do this? So what they do differently to most companies is, after they integrate the data from their source systems and have it in this data platform sort of layer, they first propagate that into the ontology layer that in simple terms consists of object types, which are basically the categories from before when we were exploring ontologies. So let's take the aviation industry as an example. The object types might be carriers, routes, and airports, to keep it simple. Within each object type, you have the properties of the object type. So for the airport object type, the properties might be the name, the number of terminals, and the number of gates. I'm showing the other properties for the other object types as well, so that you can look at it if you'd like. So within that, you have the property value, which refers to the real-life occurrence of an object. So, for example, the property value for the terminal's property of the JFK International Airport would be 5 because they have 5 terminals. Then you have link types between objects. For example, carriers fly to airports, or airports receive carriers, and carriers service routes, or routes are serviced by carriers. And then a link would be the specific occurrence of that link type. So for example, American Airlines flies to JFK International Airport. Then in Foundry, you also have action types on the links or the objects. This would be, for example, a carrier canceling a route. So you're able to see how this can get pretty complex when you have more than 300 data sources, even more object types, even more link types between those objects, and then even more actions to be taken on these links. So it's a pretty complex problem and a commendable solution to develop on a general scale, technically speaking, and in my opinion, where you have to manage this whole ontology and the edits made to it by all the users of large enterprises, some of which are 100,000 plus employees strong and in real time. I'm going to split this video here, but the next video, which is going to be uploaded at the same time, will be a direct continuation of this one. You can watch it now if you wish, or take a break, take in this information, and come back later for the next part.